Hi everybody, welcome to lesson 4 where we're going to look at our complex numbers as solutions to quadratic equations. So today is all about the quadratic formula again, and we're going to explore how complex numbers are answers sometimes. So that b squared minus 4ac thing is under the radical, right? If I have x equals negative b, I have 3 there, plus or minus the square root of b squared minus 4ac. That's the thing that we type into our calculator, all over 2a. That b squared minus 4ac has a fancy name called the discriminant. And it's called the discriminant because it discriminates on what type of roots a quadratic gets. So it tells me, do I have 2 roots? Do I have no roots? It discriminates. That number itself is the thing that decides how many roots we have. So find the discriminant for the quadratic equations here. And what does it tell us about their solutions? So all I need to do here is find b squared minus 4ac. So b squared, 36 minus 4 times 1 times 9. And again, that's what we type into the calculator, no square root, just that value. I don't have my calculator pulled up, so I'll just use a separate one that's not on my computer, and I get 0. So what that tells me is I have 6 plus or minus the square root of 0 over 2, if I was to do the full quadratic formula. If I have plus or minus 0, well, that's 6 plus 0 and 6 minus 0. So the final answer here is always just 3. So sometimes we get one repeated root. I have one repeated root here because my discriminant was 0. When that b squared minus 4ac is 0, you're only getting one repeated root, and it happens to be real. So let's add that in, one real repeated root. It's a real number. You happen to have 2 of them. It has a multiplicity of 2. Let's try it again here. Notice, there's no b term. The b term is missing, so 0 squared minus 4 times 1 times negative 9. That's what I'm typing into my calculator here. Negative 36. So this tells me that I have 2 real zeros because I have 0 plus or minus the square root of 36 over 2. So I have plus or minus 6 over 2 gives me positive or negative 3, which I could have got if I did difference of squares. But what this tells me is I have 2 different real zeros. I have positive 3 and negative 3. So when the discriminant is 0, you get one repeated root. Any positive number, you're getting 2 real zeros. And worst case scenario is over here, 0 squared minus 4 times 1 times 9, right? 1, 0, 9 is my A, B, and C. I get negative 36. So I get 0 plus or minus the square root of 36 over 2. This is a problem because this is not a real number. We can keep solving it, though, because I know the square root of negative 36 is 6i. So I get plus or minus 3i are my 2 solutions. So I get 2 complex solutions. 2 complex, 2 non-real answers, 2 non-real solutions. So that's what happens when we solve quadratics. I get 2 real answers. I get 1 repeated root, which is really 2 answers because it's repeated, or I get 2 non-real, depending on that discriminant. Is it positive, is it 0, or is it negative? And that's all we're doing today is practicing the quadratic formula. So consider this equation here, 3x squared plus x equals negative 7. So the first thing I need to do is get this equal to 0 by adding that 7 over. So now, if I want to know the value of the discriminant, that's the b squared minus 4ac. And then again, we know what 1 squared is. 1 squared is 1. Do that squaring in your head there. And now I just need to type this into my calculator over here, and I get negative 83. So since the discriminant is negative, I have 2 non-real solutions. I have 2 non-real, which means they're complex numbers with i's. 2 non-real solutions is what this tells me. So let's find them. Let's find them. X equals negative b plus or minus the square root of b squared minus 4ac, which we already found. So I'm just going to write that down. All over 2 times a. And then again, we're going to come over here to Scrapland and say, all right, the square root of negative 83. Well, the first thing we're going to do is we're going to take out that factor of I, that imaginary unit, to make the square root positive. And I don't think I can do anything to 83. So I get negative 1/6 plus or minus radical 83 over 6i. And that right there is my solutions. So again, we're going to use the quadratic formula today. You might find it helpful to compute that discriminant first on your own, which might be a step you do. So find all real and complex solutions to the following equations. All right, letter A here. X squared plus 2x plus 1 equals 0. So, all right, x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times 1. And now we type in that radical. We type in 4 minus 4 times 1 times 1. I type the discriminant into the square root, and I get 0 into my calculator, and I get 0. Well, this tells me I have one answer, right? Negative 2 plus 0, negative 2 minus 0 is negative 2. So my solution is I have a repeated root here. X equals 1 is a repeated root. That is my solution. 3x squared plus 12. So first of all, notice that I could divide everybody by 3 here, right? X squared plus 4 equals 0, which you should recognize already has complex numbered solutions, but let's use the quadratic formula to see that. Let's use the quadratic formula to see that. I get x equals negative, I don't have a b, plus or minus the square root of 0 squared minus 4 times 1 times 4 all over, again, I divided by 3, 2a 0 plus or minus the square root. Apparently I attached my surface again. All right, type this in. 0 squared minus 4 times 1 times 4 is negative 16. But wait a minute, I know what the square root of negative 16 is. It's the square root of 16i, which is 4i. 0 plus or minus 4i over 2. So I get that 0 plus or minus gives me positive 4i over 2 and negative 4i over 2. So 2i and minus 2i. Those are my solutions. All right, not bad. Not bad here. Oof, this is not equal to 0, so that's got to be our first step. 0 equals 2x squared minus x plus 5. All right, here we go. Quadratic formula time. A equals 2, b equals negative 1, c equals 5. X equals negative b plus or minus the square root. You need to square a negative. Whenever I square a negative real number, it comes out positive. B squared minus 4 times a times c all over 2 times 2, which is 4. All right, now I need to type this on in here. 1 minus 4 times 2 times 5. Type in my discriminant, which comes out to be negative 39 over 4. Well, the square root of 39, negative 39, is radical 39i. And when I think of 39, I think of 13 and 3, but those aren't perfect squares, so we're done. 1/4 plus or minus radical 39/4 with an I next to it. Those are my zeros. And again, I'm not surprised they're complex because my discriminant came out to be negative. All right, so again, we're just practicing the quadratic formula today. This one's nice and already equal to 0, so here we go. X equals negative b plus or minus the square root b squared minus 4 times 3 times 2 all over 2a all over 2 times 3, which is 6. So now I need to figure out what my discriminant is. My discriminant, I just yawned there. 16 minus 4 times 3 times 2 gives me negative 8. So I get negative 4. I don't need a highlighter. I get, where's my dark blue? There it is. Negative 4 plus or minus the square root of negative 8 over 6. So I do have complex number zeros. So I'm going to take out an I and then split that up as 4 and 2. So 2 radical 2i. So I get negative 4/6 plus or minus 2 radical 2/6 with an I, right? I replace that square root with that 2 radical 2 and that I. So my final solutions are 2/3 plus or minus radical 2/3 I. Those are my solutions. And I'm writing them in real plus imaginary form. Make sure you're splitting it up. Make sure you're splitting it up by A and B. So you have a real part and an imaginary part like every complex number should. Oof. These numbers are very large here. Hopefully I could do the quadratic formula right away, but well, I can divide everyone by 8. There we go. That made this a whole lot easier. I made this a whole lot easier here. All right, here we go. If I left that 8 in there, I'd be doing it, but my square roots would be getting really, really, really big, and I don't want to deal with that. So here we go. X equals -1 plus or minus the square root of 1 squared, which is 1, minus 4 times 2 times 8, all over 2 times 2, which is 4. And again, it's the same process every time. Type in my discriminant, 1 minus 4 times 2 times 8. I get -63. So x equals -1 plus or minus the square root of -63 all over 4. All right, when I see -63, well, first of all, I'm taking out that -1. And then 9 times 7, well, that's 3 radical 7. So my final answers are x equals -1/4 plus or minus 3 radical 7 over 4 I. And again, there's nothing I could really simplify there, but that is my final answer. And the last thing in this lesson here is letter F. So we get, what do we get here? Nothing I can GCF, nope. So x equals +4 plus or minus the square root. -4 squared is 16, because when you square a negative real number, you get a positive back. -4 times A times C, all over 2 times A. So I'm going to type in my discriminant here. And now I notice, wait a minute, there's no i's involved here. There's no i's involved here because it's a positive under my radical. I have real solutions here. I have real solutions. So now I have to deal with this 520 thing. So notice there's going to be no i's in my answer. There's real numbered solutions. This parabola crosses through the x-axis. So the first thing I notice is I can divide it by 4. Which gives me 130. And I don't think I can divide 130 has no perfect squares factors left, because 130 is 13 times 10, and that's 5, and yeah, there's no perfect squares that go into 130. So it's 2 radical 130. So x equals 4/18 plus or minus 2 radical 130 over 18. Which leaves me with, as a final simplified answer, 2/9 plus or minus radical 130 over 9. Notice there's no complex numbers. These are real numbers that I could type into my calculator and get a decimal for. All right, so hopefully you feel good with using the quadratic formula, and whenever there's a negative in your square root, all we do is we take out a factor of I and make the square root positive. Thanks for watching.